Well, hello everyone. Welcome to this Wind Power Engineering and Development webinar, Designing Effective Wind Farm Networks. I'm your host, Paul Dvorak, editor of Wind Power Engineering and Development magazine. Thank you for joining us. Now, just a brief agenda before we start. This webinar will be available at windpowerengineering.com, and a link to it and the slides will be emailed to everyone. At the end of the presentation, we'll have a brief question and answer session. Now, of course, not everyone that wanted to watch today's webinar could do so, but you can help them learn from it by tweeting the key points and takeaways you think important. In your tweets, be sure to include the hashtag WindWebinar. Now, to the presentations, I'll read the questions that you and the audience have submitted. And you can do that by typing them into the questions box on your GoToMeeting panel that should be to the right of your screen. I suggest you type them in as the questions come to you, rather than waiting until the end. We'll try to answer as many as possible before our time is up. Now let me tell you a little bit about our speakers. Our first one, we'll hear from Diane Davis. She's Director of Product Marketing for Red Lion's Industrial Networking Products. With more than 20 years of product management experience, Diane has extensive networking communications knowledge in the commercial and industrial markets. And then we'll hear from Todd Redundancy. He's an application expert for Ethernet networking at Red Lion Controls. Todd has more than 15 years of experience working with customers such as GE, Wind Power, deploying automation and networking solutions in industries that include wind, solar, and others in renewable energy. And from there, let's go to Diane Davis. Diane, the microphone is yours.
Thank you, Paul. Thank you, everyone, for joining us today. As Paul mentioned, Red Lion and through its product lines from Intron and SixNet has had a long, much experience dealing with wind farms through GE and other turbine manufacturers and keeping the networks up and running. So we have some tips and want to discuss that with you on best practices for making sure that your network is up and running so you can monitor and control your expensive assets. So today we'll talk about marketing trends and conditions and the best practices to maximize uptime. That includes ensuring reliability, building redundancy into the network, planning for scalability or expansion of your wind farm, the things you can do to simplify installation, advanced management capability, and then Todd will cover some real-world deployment examples. The first thing I would like to talk about is market trends and conditions. It's amazing how wind power has taken off. It's now present in over 75 countries. 24 of those countries have over 1,000 megawatts of capacity that's been installed. In 2011 alone, over 23,000 new wind turbines were deployed globally, bringing the worldwide total to over 199,000 wind turbines. And there's been concern in the last year about some of these, particularly in the United States, about the energy tax credit, the production tax credit being renewed. Fortunately, that was renewed for 2013. So the outlook is still very good. Market forecasters predict continued growth for the next 5 years. As you can see in this slide, the U.S. still has the world's second largest cumulative wind power capacity. There's tremendous growth right now in China and India. So there's a lot to look forward to as we continue to look for alternate renewable energy capability. You know, one of the things to take into consideration is wind farms, by their very nature, are put in very extreme conditions, and that means the networking equipment is too. So from fluctuating temperature to high humidity, even high salt areas, the heavy dust and high lightning areas, high vibration levels by their very nature, turbines create high vibration as they tilt the blades to maximize power production capability. There's extensive consideration that has to be taken for EMI interference and the vast location. The wind turbines, we work with wind farms that have well over 200 turbines installed, and it covers a very, very wide area. So centralized monitoring becomes a big concern. So what can be done to help manage these typically unmanned, very remote sites? You know, it's very difficult and costly. You're not going to have somebody on site not only at each turbine, but the wind farm itself. So remote monitoring becomes critical, not only to optimize power generation, but to proactively predict and prevent failures. There are a lot of sensors that go into these turbines that let you know whether there's been a sudden change in vibration levels, which could mean bolts are becoming loosened. Or even in the hydraulics, the oil, they check for dust particles. All of that data has to go back to a central monitoring location over the network. So we try to make sure the network will always stay up and running. The turbine manufacturers have really embraced Ethernet as the vehicle to pass this data back to the monitoring station. So we want to talk to you about what you should look for as you're building these networks. You know, why is design reliability in the network so important? Well, unscheduled maintenance visits account for as much as 75% of the total turbine maintenance costs. You know, if you have to bring suddenly a technician, if you have a downtime, out to these remote sites, it's very expensive for them to schedule the time. The parts won't necessarily be there. And the downtime can go from a planned preventive maintenance of perhaps 4 hours to up to as much as 14 days, because you have to get the equipment out there to get up to the turbine. If something actually breaks, it becomes a very expensive maintenance cost, and we're trying to prevent that. We want to get the data back to the central location so they can do condition monitoring. So what are the best practice for the network itself? One of the things to consider is that all networking devices are not created equally. Standard commercial grade networking devices, for instance, are not designed to go in these extreme environments. They're designed for temperature controlled environments. They also are not designed with wide temperature operating temperature ranges, tolerance to the high shock and vibration levels. And again, remember, up in that wind turbine, the networking equipment's being exposed to those same severe levels. Extended noise immunity and high mean time between failure. Even among industrial devices, they're not designed to accommodate the same level of extreme conditions. So let's take a look at that. A typical commercial switch has an operating temperature that's in the 0 to 45 degree centigrade range. A typical industrial switch can be anywhere from minus 40 degrees C to 85 degrees C, designed for very wide operating temperatures. On the shock and vibration levels, a typical commercial switch is 1 to 5 Gs, anywhere from 1 to 5 Gs. A typical industrial switch can be anywhere from 5 to 10 G vibration and shock to 50 to 200 G levels. I mean, it's incredible. It's like putting a switch in a paint shaker, basically. So they're designed to withstand that wide variance in vibration and shock. They're also designed to handle ESD or overvoltage protection. Not only important as these wind turbines are way up in the air and exposed to lightning, but you're in an area where you're producing power, so there's going to be variance. The mean time between failures is also a significant factor. Commercial switches at 25,000 hours, it's less than 3 hours predicted life in a commercial switch, whereas a typical industrial switch is designed to last up to 20 years or more. So again, they're designed for rugged environments, long life, and reliability. We don't want anyone having to worry about replacing the network device. So from scorching heat to Arctic cold to high humidity, industrial switches are designed to work in the same environment as the wind turbine itself. Now, building redundancy into the network, we can't tell you any single way is the best way to lay out where the switches are positioned in the network. But we can tell you that designing redundancy into the network is a best practice. From the single highest point of failure, which is usually a power supply, to building in redundant connections is critical. You'll see in this example, typically there's a switch up here in the hub, and then it goes through a slip ring into the nacelle. From the nacelle, where all the sensors are feeding data into the switch, it goes down to the tower. Typically down the tower, there's another switch. So we recommend in the tower that there's redundant links, so that if there is a point of failure, there's another path to get the data out. Also, typically in the tower, because of the sheer distance, these towers now go anywhere from 100 feet to over 400 feet in height, that fiber cable is used. And then we'll give you some examples later of the possible topologies to use in a wind farm environment. Ring topology, while it might not, sometimes it's not used in the turbine itself, is an excellent choice to provide redundant paths between each switch in the network. What happens in a ring topology, as opposed to a linear topology, if you didn't just had a straight path and this segment was broken, suddenly your data stops going to all these other devices. By simply installing a ring, the ring manager will block one communication port, and the data then will go around to these other devices. The manager will send a health check packet to make sure that the ring is intact, and upon detecting a break, it will heal the segment that was originally broken and can change the path. So data is ensured to continue to follow along. This is really one of the things we do recommend in a wind farm environment. Using ring topology for redundancy is an excellent choice. And Todd will get into some examples of that in a few moments. As I mentioned, what the ring manager does, and you can see here in our example, and this is an example of an Intron device, the ring manager will transmit the health check packet around the ring. If it detects a problem, it will heal the ring in less than 30 milliseconds. And there are tools to be able to go in and look and see the ring is okay, or if there's a break, it will automatically tell you where that break occurred. When the loop is broken, the ring manager flushes its MAC addresses and converts to a normal non-blocking switch and a daisy chain backbone. And again, it keeps the network up and running until someone can diagnose the problem. So planning for scalability. Ethernet, again, is an excellent choice because devices can seamlessly integrate into the network. In a ring topology, with Intron switches, we have a protocol called NRing for managing our rings, and it seamlessly supports up to 250 managed switches in the ring with no degradation to the 30 millisecond healing time. So we can support a very, very large wind farm. Fiber optic cabling is also an excellent choice because of the distance it can cover. Using single-mode fiber can go as far as 80 kilometers, again, providing not only distance and the vast expanse of the wind farm, but providing EMI immunity. Another consideration is these very remote wind farms, you don't necessarily have a certified network engineer being able to go out and deal with the networking capability or replacing and installing switches. So some of the things to look for, and again, all products are not created equally here, minimizing configuration through plug-and-play capability. Do your network devices have automatic configuration? Can they automatically negotiate port speed and detect cable crossover in the case of using copper Cat5 cable? Is there an automatic setup for communication with your process control device? In other words, for example, automatic IGMP configuration. Can it detect groups? Can it set up router ports and filtering by itself? These are things you want your maintenance people worrying about your turbine, not the configuration and health of the network. Simplified ring configuration. An example is with the Intron products in an N-ring configuration, all that has to be done as the manager is set up and it automatically configures the rest of the ring devices. Does your switch have backup and restore capability? And in the case that there is any kind of failure, can you automatically pull the configuration off of the existing switch and replace a new one with ease? All of these things help simplify maintenance of the network and keeping everything up and running. Can the network automatically detect change? If new PLC is put in and the port speed changes, will it automatically detect that? Other things to consider, and again, different wind farm networks use different types of products. We have manufacturers using unmanaged switches to monitored switches to managed switches. And while we would advise the use of managed switches because of the capability of rings and diagnostics, certainly there is no one way of doing things. But if you do use managed switches, there are advanced management capabilities that are becoming very useful in today's wind farms. Quality of service allows packet prioritization, and we're finding that that's extremely beneficial in sites where now surveillance cameras are being put on the network through the use of IP cameras. Also, the use of VLANs to help segment the network for very large wind farms that have more than 254 devices or IP addresses available, which is a limitation of the network topology itself. Another thing to consider is what kind of advanced monitoring is there? You don't want to have to go on-site with an expensive monitoring tool to detect cabling issues. So one of the things that we do with our products is have something we call InView, which is also available in our browser, these statistics, automatically send packets back to an OPC server, and OPC stands for OLE for process control, that gives not only statistics on the switch itself, but port information. It is very useful for troubleshooting configuration errors and cabling issues. For example, it gives information on the number of drop packets or multicast packets, or whether there's collisions. It's a very good tool remotely for determining whether you're beginning to have some kind of cabling issue. In this case, and what we're seeing right here is we also, in our HMI display, our new G3 HMI display, can take that data back directly. It can be done there remotely on site or in a central monitoring station. Again, same kind of information can be provided in the web browser, but you don't necessarily have to use a web browser. You can use the OLE for process control packet to be pulled into a server and served up to any HMI monitoring software package, or directly, as we're showing here, on the Redline G3 HMI panel. So Todd, I'm going to turn it over to you and let you discuss some of the real-life applications that we've seen and issues that they've encountered in terms of their network and the site itself.
Thanks, Diane. Yeah, I wanted to reinforce some of the things that Diane just spoke to, and some of the questions that I get in the field quite frequently from customers are, why is Ethernet being selected as the de facto standard in wind and in general in manufacturing, and how does it differ from what you have in your home network? And I think part of it is people assume that Ethernet that they have in their house, they're comfortable with it, they start to deploy it, but we get into these things that become much more complicated as we get into higher rates of data traffic than you would ever deal with in your home environment and these harsh environments. So we've been analyzing, and I've been on sites where troubleshooting seems to be the key. These are remote locations, not easy to get to in many instances. We're doing some deployments in India now, in areas where it's literally about an hour from any civilized areas, just because the windy areas are not always the ones that people want to live in. So we've been looking at GPS location capabilities where the towers are tied directly so that the servicing contractor that goes to the sites looking at hundreds of wind towers can identify specifically where the problem is and go right to that location immediately and address the issues that are going on in that tower. The vast majority of the installations that we're seeing right now are heavily in Asia, and then we're seeing in the Middle East. Again, India is another large growth area for wind right now. We're working on a project that's slated to complete in 2014 with General Electric. And remote monitoring is essential. Avoiding costs of repairs to go up to these towers and get any of the components often requires heavy lift helicopters. And ensure uptime and downtime is dollars too, not creating power.
Yeah, lost productivity is huge, Todd, isn't it? I mean, it's not just getting the someone to site, It's getting the equipment there to repair it, and then the downtime. As we mentioned earlier, it can be up to 14 days if you've got to order special parts and get cranes out there to get up to these towers, which is, I mentioned earlier, can be up to 400 feet tall now.
Yeah, and even cabling issues, we run into it a lot, and I think this is a good example of what we talk about when we talk about redundancies within the networks. But having the ability to identify where that break could be, I mean, you get lightning strikes that take out towers, and you get missed connections in between the devices. How do you get to those locations and identify where those problem areas are right away? I was on a job site recently where they took a fiber cable out of a cabinet, and someone reconnected it, but did not clean the cable. It got dirty, and all of a sudden they were having some intermittent connection issues. We were able to identify that with our OPC server at a remote location without even going out to the site, and just sending the operator out there to double check the cable connections and make sure that they were properly terminated. So redundant rings, as Diane had mentioned earlier, is a real key to keeping these wind farms up and operational and sending the appropriate data so that it can be made as to whether or not they need to get someone on site.
So this slide right here is an example of a wind farm with four rings going into a backbone where the SCADA data is being transmitted via the end ring. So I hope that this discussion gives you some takeaways about what do you need to do to ensure that you're building and deploying the most reliable, scalable network possible. What you can do to select the right industrial-grade equipment to maximize your uptime and guard against failure, not just failure of the network, but failure of your wind turbines, and be proactive in doing condition monitoring. You want to make sure that wind turbine's performance is at its maximum and will stay up and running. Most of these turbines are installed intending to be out there for 20 to 25 years. So you want to make sure that you're doing everything you can to minimize downtime. Reduce the number of site visits, have real-time remote access, and eliminate as much as possible the cost of sending someone on site to maintain either the network or the wind farm itself. Eliminate hidden costs by being proactive and doing preventive maintenance.
Diane, it's Todd again. And one more thing that I'll add to this too is that when we started looking at the development of networking for these environments, we also looked at it from the perspective of the engineer, who's the mechanical engineer and the electrical engineer, may not be IT experts. So the development that we took, the approach was ease of integration and not having to be necessarily a network expert to be able to identify and maintain these networks.
I love this video that shows the expanse of a wind farm. I mean, everything is not to maintain these wind turbines is not as rigorous as what has been depicted in the last year on the popular series Turbine Cowboys. But let's face it, they are in remote locations from mountains to deserts, like Todd said, and often are in very difficult conditions. So anytime you're letting not being proactive and there's an equipment failure, who knows when you'll be able to get to that site and the kinds of winter conditions or desert conditions that will allow you to go in and actually maintain the turbine. So we thank you for your time today, and we'd like to open it up for questions.
All right, very good. Todd and Diane, as a mechanical engineer, I always enjoy learning more about the non-mechanical aspects of a wind farm, such as the networks, things that keep the information flowing. So let's wrap up with a few questions, and our audience is a very inquisitive bunch. Diane, let's start with you then. Is a certified network engineer needed to maintain and manage the network switches?
Well, it shouldn't be, Paul. There are devices out there where they are very complicated and it requires a lot of setup. But as Todd mentioned, we've worked really hard to make our devices plug and play all the way down to the ring itself. So that's something that our turbine manufacturers and our system integrators need to really look at when they're selecting a device. Does it have plug and play capability? Is it an intelligent device? can I just plug it in and pretty much walk away and let it maintain the network? So the answer is yes, it could be, but it shouldn't.
I see. Okay, good. And another reader asks, with these rings of networks, is it possible for somebody to check the wind farm by internet?
Absolutely. Managed switches typically have a web browser, and even through the NView capability that we talked about through the OPC server, they can monitor those statistics remotely. So again, health check packets on the ring shows whether there's a ring break, and NView shows lots of information about drop packets and collisions and the amount of data being transferred in general, including how far the switch is being used to capacity by port.
Okay, maybe you answered some of this. Well, another reader asks, or listener asks, what tools are available to troubleshoot cabling and other issues remotely?
Todd, do you want to take that one?
Yeah, that goes right into what Diane's been talking about with the OPC server and NView and the ability to pull up things like frame check sequence errors or alignment errors. Alignment errors are typically related to fiber optic misalignment. We see a lot of fiber cables that could be poorly terminated. We've also seen some cables that have been coming in from overseas where they overuse the die, and on the Cat5 cables they overcrimp the connectors, and you get what's known as lazy pins. We can identify those as well with the troubleshooting tools. When you start seeing alignment and fragment errors and FCS errors, we can identify those in the network as a potential area for cabling issues. So.
Okay, very good. All right, here's a question I would ask as a mechanical engineer. What maintenance do you recommend for the fiber optic system? For example, periodic cleaning of connectors, perhaps?
Diane, do you want to take that one?
Oh, well, typically we, Todd gave a good example of somebody that went out and did some maintenance or moving around of cables and got a cable dirty. But typically, once it's installed, there's not an issue.
Yeah.
Okay, here's a good related question. Do you also work with wireless networks in these areas, or is wired the only option?
Now, wireless,
we do.
Absolutely. I'll hand this over to Todd, but we're getting more and more questions every day, particularly in older wind turbines where they're looking at retrofitting installations that perhaps weren't installed using Ethernet to begin with. Todd, do you have some examples?
Yeah, we have actually had an application in the U.S. and upstate New York where we didn't have, it was a remote location, but there was actually cell service out there, and we're analyzing the ability. We have, when we say wireless, there's two versions of wireless. We have Wi-Fi like you'd have in your home, and then you have wireless, which would be cellular-based. So we're able to do both. What we can do with a cellular-based modem is we actually have the ability to set up GPS location services, so that would identify if you had one of these located at each tower, which tower was giving you the problem and its coordinates, so that you could get the person on the job site at that location. There could be flags that would be set up to send out notifications of cabling issues as well. So you could have this thing sort of monitoring itself and sending out to someone at a remote location that there's a problem and it needs to be addressed and where it is.
Excellent. Here's another question. Does Red Lion support integration needs with interconnection utility systems, or would that be handled by others?
Typically, we can support our customers to put those in, but we're not in the integration business. We rely on partners that would go out to do those service-related calls and support of these wind farms. And we're finding now that a lot of the older wind farms coming offline, as far as warranty coverage is concerned, that there's sort of an upsurge of potential for folks to get out there and start learning about the towers to be supporting the maintenance of them on an ongoing basis.
I see. Good. Another one for you guys. What's the most common failure point in these types of systems? Is it usually related to user error, equipment issues, installation, or maintenance?
Todd, would you like me to take that one?
Yeah, go ahead, Diane.
Typically, the highest point of failure in the turbines, not even necessarily the network itself, is electrical. So in the network, we look for redundancy for the power input, because it's a lot like our PCs at home. That's why industrial devices don't use fans like a computer, and we offer redundant power inputs because the power source is typically the highest point of failure.
I see. Very good. Okay, another one for you guys. Who is the typical customer for the switches? Is it the wind turbine manufacturer or someone else?
It's really both. Todd can address this too, but we work with the wind turbine manufacturers. We work with system integrators, and also now, as some of these turbines do come out of warranty, we're dealing more and more with the service suppliers. Todd, do you have any comment on that?
Yeah, we're seeing some of the older networks where they're looking for now upgrades into the wireless, where some of these towers don't have Category 5 cabling, but they're looking to upgrade to Ethernet, some of the early deployments. So running a 400-foot cable exceeds the Cat 5 standard, so they're looking for fiber cables and termination of fiber. And I'm seeing a big upsurgence now in maintenance-related out-of-warranty, service providers that are going on to these sites now and really need to understand what they're getting into when they get there.
But Paul, it's really a mixed bag even with the new installations. Typically, the turbine manufacturer works with a provider, and the switches that are in the tower itself, they take care of, and then between towers, it's usually an integrator.
Yeah, I see. Yeah, that makes sense. Okay. Diane, here's our last question. And this is from James. He says, can the IEC 61850 KEMA certification be obtained from Enron?
From Entron? We both, under our 6net product line and Entron product lines, we do have 61850 certified products. KEMA's test lab, much like UL, and they're testing to the 61850 standard. So the answer is yes, we do have products available.
Okay, very good. That answered all our questions. Once again, this webcast will be available at windpowerengineering.com. Just one final message. You can follow Wind Power Engineering and Development on Facebook, Twitter, and LinkedIn. This concludes our presentation. I'd like to thank the audience for your attention. And from the staff here at Wind Power Engineering, we wish you a good and productive afternoon.
Thank you, Paul.
Thank you.